Module 1. Introduction to Disaster Risk Management. Disaster Risk Management. Where we stand. This introductory module will give an overview of natural hazards and disasters all over the world. Provide definitions and frameworks to assure a basic common knowledge and consistency. Introduce the most significant players in the international context and present coping techniques, showing differences between former and current practices. Earthquakes, storms and other hazards killed about 3.3 million people between 1970 and 2010, which is an annual average of 82,500 deaths worldwide in a typical year. Disaster risk arises when hazards interact with physical, social, economic and environmental vulnerabilities. Events of hydrometeorological origin constitute the large majority of disasters. Despite the growing understanding and acceptance of the importance of disaster risk reduction and increased disaster response capacities, disasters, and in particular the management and reduction of risk, continue to pose a global challenge. The Center for Research on Epidemiology of Disasters, CRED, defines a disaster as a situation or event which overwhelms local capacity, necessitating a request to national or international level for external assistance, an unforeseen and often sudden event that causes great damage, destruction and human suffering. For a disaster to be entered into the MDAT, a specialized disaster database, at least one of the following criteria must be fulfilled. 10 or more people reported killed, missing or presumed dead. 100 or more people reported affected. Declaration of a state of emergency and/or call for international assistance. In 2007, a new classification was introduced in MDAT. This classification is a first step in the development of a standardized classification of disasters. It distinguishes two categories of disasters, natural and technological. Natural disasters are biological, which comprehends insect infestations, epidemics, and animal attacks. Geophysical, earthquakes and tsunamis, volcanic eruptions, dry mass movements such as avalanches, landslides, rockfalls, and subsidence of geophysical origin. Climatological, droughts and associated food scarcity, extreme temperatures and wildfires. Hydrological, floods, inundations, waterlogs, surges, and meteorological, storms. Technological disasters are industrial accidents, such as chemical spills, collapse of industrial infrastructures, explosions, fires, gas leaks, poisoning, radiation. Transport accidents, by air, road, rail or water, and miscellaneous. This comprehends collapse of domestic and non-industrial structures, explosions, fires, etc. This course focuses only on natural disasters. Key caveats with disasters data include the lack of standardized collection methodologies and definitions. Data are not always complete and generally are not collected for statistical purposes. Thus, the quality of completion may vary according to the type of disaster, country, collector, national or international agencies, public or private entities, etc. Disasters affect all regions. East Asia has been hit by the highest number of disasters, more than 2,000. Floods and storms are the most common, while droughts much less so, except in Africa. Deaths are more concentrated. Droughts in Africa are the deadliest. Storms in East and South Asia also take many lives. Differences across countries suggest that some countries prevent disasters better than others. For example, the contrast in the death toll in Haiti and the Dominican Republic, sharing the same island and storms, underscores the point that disasters are man-made, not natural. We are capable of reducing the death toll even in poor countries. Moving food averts a famine despite droughts. Early warning systems reduce deaths caused by storms and floods, and so on. Floods and storms are the most common disasters all over the world in the years between 1970 and 2010, hitting for more than 60% in every region. In North America, accounting for more than 75% of the total number of natural disasters. Not surprisingly, Africa shows the highest percentage of droughts at around 30%. Central and Latin America, East Asia and Europe share the highest percentage of earthquakes, more than 20% per region. while extreme temperature are becoming a serious threat in continental Europe and South Asia. Each hazard afflicts countries differently, but many countries are subject to multiple hazards, though the importance of each differs. Earthquakes and volcanoes, geophysical hazards, tend to cluster along fault boundaries characterized by mountainous terrain. Floods, cyclones, and landslides, hydrometeorological hazards, affect the eastern coastal regions of the major continents, as well as some interior regions of North and South America, Europe, and Asia. Drought is more widely dispersed across the semi-arid tropics. Areas subject to hazards fall primarily in East and South Asia, and in Central America and West and South America. Many of them are also more densely populated and developed than average, leading to high potential for casualties and damage. But geography is not destiny. Many countries in harm's way have managed to protect their population over time. Rich and poor countries are subject to hazards, but most of the 3.3 million deaths over the last 40 years were in poor countries. Damage, however, may be rising in absolute terms, with earthquakes and storms causing the most of it. Middle-income countries are particularly vulnerable. More people were affected in the 2 recent decades than earlier. This increase may reflect greater exposure to hazards, or better reporting in recent years, or both. Half the world's people now live in cities, up from 30% in 1950. And most large and rapidly growing cities in poor countries struggle to provide public services, including disaster prevention. Many scholars believe that rising absolute damage is plausible, considering the increased exposure from urbanization. Areas in the map reflect cumulative deaths from different types of disasters for 1970 to 2010. Deaths seem to reduce over time in Latin America, North America, and Middle East, while increasing in East Asia and Africa. Africa looms as large as East Asia, and the Americas shrink, the North to almost nothing. When those areas reflect economic damages and losses instead, that population death in Africa shrinks, and middle-income and high-income countries expand, such as North America, Gulf Coast, Middle East, Morocco, Libya, and Arabic Peninsula, and East Asia, Australia, China, and Indonesia. The annual global damage from disasters between 1970 and 2010, adjusted for inflation, fluctuates like deaths, but is also rising in spurts. Damage in the recent 2 decades is significantly greater than in the earlier decades. This could reflect greater exposure, or better reporting, or both. Most of the damage is from storms, earthquakes, and floods, in that order. In addition to the economic costs of disasters, there are social and environmental impacts that are many times difficult to quantify. Some examples of social and environmental impacts of disasters include loss of human life, damage to the environment, losses of natural habitats and destruction of ecosystems, disruption of communities and family life, loss of cultural heritage assets, unemployment and migration. Disasters tend to have differential impacts on men and women, and gender is an important issue to consider in recovering, as well as preventing damages and losses from disasters. Donors usually respond to disasters after they strike. About a fifth of total humanitarian aid between 2000 and 2008 was devoted to spending on disaster relief and response. The share of humanitarian funding going to prevention is small, but increasing, from about 0.1% in 2001 to 0.7% in 2008. However, prevention activities often imply long-term development expenditures, whereas the focus of humanitarian aid, already a tiny part of official development aid, is immediate relief and response. Donors concerned with prevention could earmark official development aid rather than humanitarian aid for prevention-related activities. And such aid, if used effectively, could reduce issues arising from the Samaritan's dilemma, the inability to deny help following a disaster to those who have not taken sufficient prevention measures. Many scholars suspect that climate change is influencing the occurrence and impact of natural hazards, mainly because the number and severity of disasters around the world has been increasing. Climate change occurs because of high and low frequency natural variations and because of atmospheric pollution through anthropogenic greenhouse gas emissions. The knowledge about the impacts of climate change on weather hazards has improved considerably during the last few years, and recent changes in temperature and rainfall that are being observed have partly been caused by greenhouse gas emissions. Disasters, however, are defined by the disruption of the functioning society, involving widespread human, material, economic or environmental losses. And this is largely influenced by population and their location. New players, such as climate variability, changes in temperature and rainfall patterns, as well as population density, poverty, and geophysical characteristics, are playing major roles in shaping the new era of disasters. Natural disasters are regarded as the ultimate expression of destructive forces of nature. In the past, disasters have been seen as external events that were not preventable, not even forecastable. Most of the responses were based on the use of indigenous knowledge the elderly used to share generation after generation, such as early warning, rainwater harvesting, flood protection, especially the handmade ones, cropping patterns, thrift and credit. Neither dedicated institutions nor agencies at local, provincial or national level were designed to cope with disasters, and lack of coordination among agencies was a common denominator. Institutions that prevent damage develop more slowly than assets as countries urbanize and prosper. But this has changed drastically. Even poor countries can undertake effective prevention, and more can rise to the challenge of doing so. We will always live on a restless planet, with natural hazards covering the gamut of flood, inundation, windstorm, earthquake, tsunamis, etc. Today, more than ever, communities across the globe know more and can do more to take actions to reduce the devastating consequences of natural disasters left unchecked. Governments are now able to assess damage and losses after a disaster, and such assessments differ in scope, purpose and technique. Better access to scientific information and more sophisticated technologies allow better assessments. Measuring damage is tricky. Prone to both overestimation, for example, double counting, and underestimation, it is difficult to value loss of life or damage to the environment. Biases also affect the accuracy of estimates, especially when the prospect of aid affects incentives. Accurate measurement is more likely when its purpose is clear, though some items of interest cannot be measured. Damage assessments have multiple and often overlapping purposes. They could guide government relief, such as how much to spend on alleviating the victim's suffering, knowing that other spending must be cut or taxes raised. They could show how to hasten economic recovery or identify specific measures to improve prevention. People are often guided in their prevention decisions by information on hazards. Yet the seemingly simple act of collecting and providing information is sometimes a struggle. While some countries attempt to collect and archive their hazard data, efforts are generally inconsistent or insufficient. Specifically, there are no universal standards for archiving environmental parameters for defining hazards and related data. Data exchange, hazard analysis, and hazard mapping thus become difficult. As presented in this slide, few countries collect and archive data on hazards, even though technological advances such as the abundance of free, simple, and open source software, for example PostGIS, GeoServer, MapServer, the geonode.org project, should make collecting and sharing information easy. And even where information is collected, it is not always shared. Even though sharing information on hazards involves relatively little expense, because some government agencies already collect and analyze data on hazard risks. Systematic mechanisms for tracking information related to the changing nature of risk and translating it into risk-related property valuations would go a long way to increase the incentives for prevention. Making maps of floodplains and seismic fault lines easily accessible would make developers and property owners more aware of the risks and more motivated to build appropriately. Collecting data on weather and climate is also integral to producing accurate forecasts. When disasters struck, many players come to help recovering and reconstructing. First is the GFDRR, Global Facility for Disaster Reduction and Recovery. The World Bank and the Regional Development Bank are also involved in loss and damage assessments and recovering and reconstruction activities and projects, from infrastructure to governance. The Provention Consortium, which is a global coalition of international organizations, academic institutions, the private and public sectors, and civil society organizations dedicated to increasing the safety of vulnerable communities and to reducing the impact of disasters in developing countries. For more information, please visit its website at proventionconsortium.org. Other partners include the International Strategy for Disaster Reduction, which is the United Nations Platform for Disaster Risk Reduction, and the International Federation of Red Cross and Red Crescent Societies, which is working to bridge the gap between relief and development efforts, and currently serves as Secretariat to the Provention Consortium. Established in 2006, the Global Facility for Disaster Reduction and Recovery, GFDRR, is a partnership of 36 countries and 6 international organizations committed to helping developing countries reduce their vulnerability to natural hazards and adapt to climate change. The partnership's mission is to mainstream disaster risk reduction, DRR, and climate change adaptation, CCA, in country development strategies by supporting a country-led and managed implementation of the HUGO Framework for Action. The GFDRR is managed by the World Bank on behalf of the participating donors and other partnering stakeholders. The GFDRR operates through multiple donor funds to enable low and middle-income countries that are at most risk to mainstream disaster reduction in national development strategies and plans to achieve the Millennium Development Goals. In January 2005, 168 governments adopted a 10-year plan to make the world safer from natural hazards at the World Conference on Disaster Reduction, held in Kobe, Hyugo, Japan. The HUGO Framework for Action, HFA, is a global blueprint for disaster risk reduction efforts during the next decade. Its goal is to substantially reduce disaster losses by 2015 in lives and in the social, economic and environmental assets of communities and countries. The framework offers guiding principles, priorities for action, and practical means for achieving disaster resilience for vulnerable communities. Priorities for action include: 1. Ensure that disaster risk reduction is a national and a local priority with a strong institutional basis for implementation. 2. Identify, assess, and monitor disaster risks and enhance early warning. 3. Use knowledge, innovation, and education to build a culture of safety and resilience at all levels. 4. Reduce the underlying risk factors. 5. Strengthen disaster preparedness for effective response at all levels. The HUGO framework explains how there is a need to enhance international and regional cooperation and assistance in the field of disaster risk reduction through, inter alia, the transfer of knowledge, technology, and expertise to enhance capacity building for disaster risk reduction, the sharing of research findings, lessons learned, and best practices, the compilation of information on disaster risk and impact for all scales of disasters in a way that can inform sustainable development and disaster risk reduction, appropriate support in order to enhance governance for disaster risk reduction, for awareness-raising initiatives, and for capacity development measures at all levels, in order to improve the disaster resilience of developing countries, financial assistance to reduce existing risks and to avoid the generation of new risks. This introductory module provided an overview of natural hazards and disasters, most important definitions and frameworks, introduced the most significant players in the international context, and described coping techniques, former versus current practices. There is now international acknowledgement that efforts to reduce disaster risks must be systematically integrated into policies, plans and programs for sustainable development and poverty reduction and supported through bilateral, regional and international cooperation, including partnerships. Sustainable development, poverty reduction, good governance and disaster risk reduction are mutually supportive objectives. And in order to meet the challenges ahead, accelerated efforts must be made to build the necessary capacities at the community and national levels to manage and reduce risk. Disaster risk management is composed by three main types of interventions, which are recovering, reconstructing, and preventing risks, damages, and losses. Those interventions will be described and exploited in details in the next presentation. Figures and graphs are from the World Bank, Natural Hazards, Unnatural Disasters, The Economics of Effective Prevention, 2010. Text adapted from the World Bank, Natural Hazards, Unnatural Disasters, The Economics of Effective Prevention, 2010. L.M. Bauer, Disaster and Climate Change, Woman Print Service, Amsterdam, 2010. The World Bank and GFDRR, Understanding Risks. Proceeds from 2010 UR Forum, 2010. UN ISDR. Hugo Framework for Action, 2005 to 2015. Building the Resilience of Nations and Communities to Disasters, 2005. International Federation of Red Cross and Red Crescent Societies, World Disaster Report, 2010. 2010.